I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic on ripple counters for the course Digital System Design. So the contents of the entire presentation is, first we are going to see the recap of the previous topic, hazards, and also we are going to see ripple counter fundamentals in a design thinking way. Next is the applications of ripple counters and its summary. Finally, we are going to see the assessment part and also the references. So the recap of the previous topic, hazard. We know that hazard is the unwanted glitches due to unequal signal paths which makes propagation delays which are unequal. And here there are three different types of hazards: static hazard, dynamic hazard and essential hazard. So in static hazard, the output momentarily changes to wrong state before settling to correct state, and the dynamic hazard where the output changes multiple times instead of once, and the essential hazard is due to the unequal delays in the feedback path. So these are the different types of hazards in digital logic circuits. So now we are coming to the topic ripple counter. So there are two types of counters. One is synchronous counter and another one is asynchronous counter. And this classification is based on the application of clock signal. So in synchronous counter, all the flip-flops are receiving the common clock. So common clock pulses simultaneously applied to all the flip-flops for the operation. But in asynchronous counter, only the first flip-flops receives a clock pulse, and the next flip-flop is operated by the previous flip-flop output. So each flip-flop output is act as a clock signal for the subsequent flip-flops. So this is the ripple counter or asynchronous counter. So, because of common clock signal in synchronous counters, it makes the system very complex, and due to this complex system, cost increases. And in low speed applications, we require a simple design of counter such as ripple counter. So this is the advantage of ripple counter, and this overcomes this challenges based by asynchronous counters. So in asynchronous counter or ripple counter, the clocking is very simple and cost is low, and the implementation is also simple. And now coming to the architecture, that is the ideate part of design thinking. So this circuit shows the 3-bit ripple counter. So there are 4 flip-flops are needed. The first for this design, ripple counter design, we can use either JK flip-flop or T flip-flop. So if we see the diagram, the leftmost flip-flop receives the clock signal, and the output of first flip-flop, that is Q0, act as a clock for the next flip-flop, and similarly it goes on continuously. So LSB is the left flip-flop, and MSB, the most significant bit, is the right side flip-flop. And this timing diagram explains how the flip-flops operates. So since the flip-flop is operated by the JK flip-flop or T flip-flop, its operation is toggling, and the output, we cannot receive the simultaneous output because each flip-flop toggles. A common clock pulse is applied to first flip-flop, and the output is then goes to the next flip-flop as a clock signal. So here a toggling occur, and it goes on. So because of this reason, there is a limitation in the speed of ripple counter. So this is one of the disadvantage of ripple counter. But the advantage is it's simple clocking in a ripple counter, and this is suitable for low speed applications. So if the speed is not that much concern, we can use the ripple counter because it's simplest design and cost is low. So in the timing diagram, a clock signal and the subsequent flip-flop outputs, how the state changes occurs is given in the diagram. And now coming to the applications. So one of the very important application of this ripple counter is frequency division. So here the flip-flop divides the frequency by 2. So because of this reason, this can be useful in clock subdivision, frequency synthesis, and also in the application of timings in digital watches. And there are multifaceted applications of ripple counters. They are useful in industrial applications, timing systems, low power consumption. It's one of the advantage because of the simplest circuit, and it is having the simplicity and effectiveness. And since the ripple counter converts the timing pulses into readable digital values, this will be useful in timing systems. And advanced cases of applications are this will be useful in event counters, digital systems, telecommunication applications for frequency division, and useful in timing related devices. Since it is useful in timing related devices, it also useful for frequency division, and also very much useful in embedded systems. So now the summary. So far we have discussed the components of ripple counters, its functionality and its advantages, applications and disadvantages. So now the assessment part. What causes essential hazards in ripple counters? We know due to the delays in the feedback path. And second question, what is mod of 4-bit ripple counter? It is 16. And 32 megahertz reduced to 1 hertz. So here the frequency division have to be applied. So we can use a chain of flip-flops to reduce the frequency from 32 megahertz to 1 hertz. So far we have discussed about ripple counters and its functionality, applications, advantages, disadvantages. Now we have also discussed the assessment. References. Thank you.